Hello, my name is Andrew, and yeah, how to save an open world game. So this probably won't be relevant to everyone in the room, but I think it's at least very interesting because it's not a complexity most people will probably think about when they play their favorite games like Minecraft, stuff like that. So quick background about me, I've mostly done interactive exhibits in the past, outdoor domes and indoor like museum projection rooms, but nowadays I'm working on an open world survival game called Planetation, and that's where this talk comes from. Before I can get into how to save an open world game though, I need to quickly just touch on how to save any game. And really there's 3 difficulty levels to think about. So there's Call of Duty, that's like the very easy one. Basically we're saving which mission we're up to, and the key thing there is when you when you load a save game, you will begin play at the map that that mission is set to play. You don't need to save any state about the map or anything special, it's very, very simple. But Baldur's Gate 3 takes that up quite a few steps. Baldur's Gate 3 and other similar games let you start play at where you left off, so you can just kind of pick up and continue play. And this means that you need to track a lot of state about the world. Things like which chests you've looted, walls you've broken down, enemies you've killed, that kind of thing. But importantly, you only really load at the very start of your session, and then you save at the very end, ignoring autosaves and stuff like that. Planetation and open world games in general take this up another step in complexity by continuing to allow you to pick up where you left off last time you played. But the save games are really too big to load just at the very start of your session. So instead we have to stream them in and stream them out around you as you play, which can be quite a complicated process, especially on consoles, stuff like that. So why is the game too big to just load once and forget about it? It's because we have a procedural world that's generated from math, and it's pretty much to infinity and beyond. It's boundless. So if you just keep walking, you'll keep generating stuff, and you can end up with millions and millions of actors if you just keep on walking into infinity. This is roughly what it looks like top down. So we have a mesa biome in brown and an outback biome in red. When we generate it, we will populate this with landmarks like dead trees and living trees, a whole bunch of other stuff. And it ends up looking a bit like this. Yes, that's playing. So this is our mesa biome, just running through the mesa biome, all procedurally generated. But the key thing to note here is it's really only procedurally generated in a bubble around you, as far as you can really see. And that's because we're taking a leaf out of Minecraft's book, basically chunking our world into just relevant chunks and only loading and generating those relevant chunks around the player as they move through the world. As we continue to move through the world, we then need to unload previous chunks, so unload all of the actors associated with those chunks, but unload them in a way that we can bring them back online very, very quickly with all of their persistent state. We then need to load or generate additional actors endlessly and record them all into our save file. The way that we do that is we need to give them all a unique identifier. This one is pretty simple, but you'll see a more advanced one in a sec. Basically, we need to number them in a way that they don't clash, so we can always refer to the tree number 12 in the outback versus the number 1 tree over in the mesa. And then we can associate those unique identifiers with the chunk that contains each of these landmark actors. And then we know once those chunks become relevant, we can specifically pull just those actors out of the save file. We can stream them in and out. So some very quick code examples from Unreal Engine. This is just Unreal Engine C++, nothing too heavy. We actually identify all of our landmark actors with fgwid. So this is just built into the engine, standard global unique identifier. It's very handy because instead of doing ints like you saw on that screen a moment ago, you don't really need to keep track of what number you're up to or what the next identifier should be. You can just make one and you're guaranteed it will always be unique no matter when you make it. They just look like that, a big garble of gibberish. This is iSavable, so this is the interface. It's more of a mix-in really, but the interface that we need to implement in order to make an actor savable. It does a whole lot of stuff. I won't go into all of it, but one of the key things is it exposes the GUID, so it relates it back to the save file. But one of the most important things is actually it lets us handle game logic in relation to our streaming actors, because we don't always want to have our side effects happen. Usually when we create an actor, we begin play or we destroy them. They will have side effects. They'll register themselves to lists, or for example, we have explosive mushrooms, they blow up when they're destroyed. So we don't want that to happen every time that they're unloaded to disk, because they will be coming back up online. They're not really destroyed. So we have a bunch of helper functions like this. Is first play helps us detect if this is the first time it has played or if it is being loaded from disk. In this case, our crop class, which is just crops you can plant in the ground, will play its plant effect, so a sound and a visual effect whenever you plant it in the ground the first time. But as it's streamed in off screen in the distance again and again and again, it won't continue to play those effects. Similarly, is first auth play is very important because this is the same thing but only on the server, on authoritative server state. We often want to set up our initial state like this on the server, but we don't want to keep doing that every single time we load it from disk because that state should come from the save game file. This final example is from our building actor. Basically, when it's destroyed, similarly, we only want to play a demolish effect when it is finally destroyed, not every single time it's unloaded off screen into disk. And that's about it. I've covered two elements of save games for open worlds. I realize that was not very comprehensive, but 5 minutes. I guess the two big takeaways are you need a way to identify these things again and again and again as you stream them in. So a GUID or similar system is super important. But also you really have to keep in mind limiting your gameplay logic as you stream them in and stream them out. You don't want all of these side effects to happen every single time. That would be a complete mess. Thank you. My name is Andrew. If you have questions, come up.